All right, thanks for inviting me. I'm going to talk about human factors in secure development today. And yeah, you'll be able to very quickly figure out how this research relates to fuzzing, I think. So my main pitch whenever I give a talk is that the vast majority of all security incidents recognize human error as a contributing factor to, well, security problems. So this can involve admins, which can be system configurators, or they can have poor patch management. This can be developers who make mistakes, which will be the focus of my talk, and which can also be end users who may be using easy guess passwords or who may not comply with security warnings. So Matthews and also my research field kind of as a pitch has this like big problem of email security that in theory has been solved in the 90s. We could have confidentiality, authenticity, and integrity in theory. What we do have is, well, not so great email security in practice. So for me, it's more common to see that people attach a confidentiality notice than that they encrypt their emails. Part of the problem for emails is just that it's hard to encrypt them. You may understand this, people attending this talk, but with your parents, grandparents, or even your non-technical employees and colleagues. So another thing that has been solved in theory is authentication, right? So what we could have is strong passwords, client certificates, YubiKeys, any other type of hardware authentication. What we do have in practice is terrible passwords that are being reused all over the place. So password research has kind of tried to fix this, but it's just hard for people to remember and create 300 plus unique passwords. And then here's something where developers come in. So password managers could solve this problem and remember things for users, but they also depend on website cooperation, and websites are configured by webmasters. And yeah, you're basically supposed to do no funny stuff in order for password managers to work. So this is also not an easy fix, and it's a fix that depends on tech people getting it right. So talking about developers, they're experts, right? They should be able to do all those things, solve all the problems, and do security correctly at all times. But they happen to not always be security experts. So I don't know if you remember, but for me, this has been pretty recent. So if we think of the Heartbleed vulnerability that existed in an open source library that was widely used to implement secure network connections, and this existed for years before it was caught, even though in theory, people were able to look at this and analyze this code and find problems. But it's also not maybe developers' fault entirely, because it's also unnecessarily complicated for them to do their job. We have unsafe API defaults that may mess with their job. We may have terrible documentation that may suggest to do insecure things. And we also may have terrible tool support that if it does support people to do something quickly, functionally, it may also be messing with their security. So in my research, I try to get away from this question of why are developers super lazy? Why can't they just, use all the right tools, do all the right things, know all the right things to do? And I'm trying to move more towards how can we make secure programming easier for people? So for the last many years, I've been studying developers. It's harder to study them because it's harder to get access to them, but it's also really impactful if you meaningfully study them, because what you do with them and what you can teach them, and if you can help or support them fix security, this just has huge impact on all the users of all their software. So let me quickly talk about some of the research results that we have been able to get. So one of the main results, which was also honored by the NSA, was that we were able to look at this saying that everyone knows that Stack Overflow is insecure and it's a terrible idea to copy and paste code from the internet, especially terrible for security, because any code you write may eventually end up in production code. So especially for people who don't know how to really interact with the code that they may be copying and pasting, this may be a terrible idea. But no one had ever done any type of study and measured this in practice. So this was one of the anecdotes of, well, don't do this. This is terrible. So we were able to measure this. And we started with an online survey where we talked to a lot of developers that we recruited about how they program and which online help they use. And we can see that the main resource they go to is Stack Overflow, this online question and answer platform where people post questions and other people reply with code snippets. And then in a lab study, we were able to isolate which resources they were able to use to see whether or not this had an impact on the security of the code outcomes. And then later, we were able to take the results that we got in the study and look at a large amount of apps and just see if what we found actually generalized outside of our lab into the real world. What we found was that only about half of the working results that used Stack Overflow solutions were secure. This is compared to 86% of results that were using the official documentation instead. So the problem now is, like, what are you supposed to do? People are going to check online, right? So should you cut off the internet, give people a book, and then just force them to use secure resources? So no, what we really took away was that with this peer support that's not really supervised, you can get quick functional solutions, which you can't get with official documentation that doesn't have peer support, but it's less secure. So we need to integrate resources that are both helpful but also secure. So another topic that a lot of research and also mine focuses on is that cryptography is hard for developers. Even the bad guys fail at cryptography. So there were a lot of headlines where people who created ransomware for a living needed online support in actually getting their crypto right. So this is not really a motivation problem, because who is more motivated to get crypto right than people who may go to jail if they don't do their ransomware correctly? So the question is, if people design cryptographic APIs specifically for usability, does that lead to better security? And we investigated this research question in an online study with Python developers. And we found that depending on library and tasks, secure solutions range from around 10% to around 90%. So really depending on what people were using and what they were supposed to do with it, they were able to either do nothing securely or do everything mostly securely. And then this is really scary. 20% of the people that did these things thought their solution was secure when it was actually insecure. So we found that even usable libraries were not really good at telling people when they messed up. So they thought, oh, my code is running. This is awesome. I can send this in and I'm good. In 20% of the cases, this was actually not true. So everything was running is fine. They thought it was fine and it wasn't. So what made a difference here was if something was designed to be usable, kind of like Stack Overflow, it did help them get functionality right. So they were able to quickly get solutions. But designing for usability did not necessarily lead to really good usability. So some libraries that said, oh, we're really usable and we did this on purpose, were just not. And then also good documentation could make a difference. So if you have low-level functionality and really helpful documentation, that would help people get secure results quickly. And then also full functionality was important. So if you just wanted to be usable and you took away most of the options, then people would still not be able to solve problems. And then in real life, which is most of the code that's being written is not being written in lab studies, libraries that don't have full functionality are just not going to be used. So you're basically forced to give people the option to mess up and then document really well what they should and shouldn't be doing. So the big question is now, how do we support developers with secure development? Because as you can clearly see, if you just leave them to copy and paste stuff from the internet, the results may be software that runs. But if you think about use cases that are maybe more important than a gaming app, so if you think, for example, about cars, you just don't want something that runs on a good day, but that is not secure. So the research results that we have is that usable documentation supports secure software development. So if you're able to give developers documentation that is, of course, secure, but that's also really usable, and where they can search for problems that they can come up with, and where they get configurable code examples, that's something that can help with secure development. And then maybe importantly for this audience, tool support supports secure development. So in one of our studies and in multiple other academic studies, we were able to show that tool support that flags problems and makes easy to fix suggestions is going to be able to help developers program securely. And then a really important finding, and one that I haven't seen so much, is that organizational culture supports secure development. So in one study, we found that company security culture that is really strong and employee security mindsets co-develop and last for a long time. So we talked to people who had been working on crypto and selling crypto to governments, and they had started out in companies that had really strong security cultures and that helped them learn on the job how to have a strong security mindset. And then wherever they went, so whether they founded a startup or whether they switched jobs completely and switched fields completely, they took this strong security mindset with them. And then also, if the new company or if the new startup didn't have their own security culture, they would influence the culture and just bring what they had learned and their habits with them and help the new company develop a similar strong security culture. So this is a secure development lifecycle that in 21 interviews with crypto experts, we were able to extract from the processes that they told us they had. And basically what you can see here is that they did anything and everything in order to make sure that their code was secure and that they wouldn't be relying just on the stuff that's external, like bug hunting later or pen testing later, but that they were thinking about security all the way through their specifications and requirements and all the way through their development lifecycle. And as you can see here, testing plays a huge role. And we can see here that at least for people who are crypto experts and who sell crypto software to governments, fuzzing also plays a big role. So another thing that can support developers is warnings in libraries. So we were able to show in a study where we co-designed warnings with developers that if you have really good and really usable warnings that give actionable advice, you can show them at compile time, and then that can also help with code security, because developers will actually stop in their tracks, take the advice, and then be able to fix security problems. And mainly the focus of my research is that understanding developers' motivations and behaviors is going to be the thing that allows us to support secure development. Thanks. Finishing early. Maybe I talked too quickly. So if you have any questions, this is now already the time for questions.
Okay, thank you for that. I'm always happy to hear about the human aspects. So I only got one question via direct message. So so we have an anonymous question. Someone saying that they're working in automotive software development and the documentation is really terrible. and the company culture also doesn't value security. And you mentioned both those things as being important. Do you have any recommendations how a company can actually improve these two issues? So how can you motivate developers to write better documentation, and how can you motivate companies to develop a better security culture?
So thank you for the question. That's a really good one, and I've gotten that one before. So I feel like the main thing you need is buy-in from the top. So if you are in a company where leadership values and rewards and makes hiring decisions and makes promotion decisions based on good security and good security habits, you are probably going to be successful in instilling a good security culture in employees, or rewarding employees that already bring this good security culture. If you work in a company where, and that's not just something that I'm saying, that's like a research result from other researchers that study the same field. So if you have a company that doesn't value that, or that thinks that they don't have money for this, or that just thinks that security is annoying and is not a major thing that you should care about, then it's just going to be really hard to try from the bottom up to develop these mindsets, because you may just be seen as the annoying person who holds everything up. So I feel like my advice to people at the top would be to really treat security as a core value of the company, and then make sure that actions reflect that, and that you plan enough time, money, expertise, and hiring decisions around security. But if you are if you're not one of the people who is able to make these decisions, of course you can do all the right things, but then you run into this conflict of, well, you may only have functional requirements, and you only have this much time to hit them. So if you don't have fantastic tool support that does security automatically for you, without additional time, it may just be really, really hard from, starting from within the company, but not from the top, to get this security culture installed. And what was the
documentation?
Documentation, yeah. So what we've been working on, and what's been really interesting to do, is the main thing would be document not for the decisions that you made. So that would be an internal document, more or less, that you write, which is important to write for people to continue, working on this project whenever you've left, or for you after 6 weeks and after you've forgotten what you did, to continue working on the project. So documenting your decisions is good, but this is not the documentation that should be visible, or should be facing towards the people who are users of your documentation. So if you develop documentation for other people that are not your developers, we kind of say you're not your developer either. So you have to figure out what are their use cases, what are they going to want to do with your product, with your software, and then what do they need to know? So what they probably do not need to know is why you made decisions, but what they do need to know is, what is a good example of doing the task that they set out to do? So, and then also, how can they configure this? And then majorly, if they get this error message, if they get this warning message, what are they supposed to do with it? And a really good tip is maybe to rely on data that is being created as you have your product out there already. So you can just maybe search for problems that people have had with using it, and then search for problems that people may have posted on these peer question answer platforms. And you may just be able to take the problems that people have had and really give good examples and solutions in your own documentation. And then when you do that, this is going to remain the main resource that people are going to use if they try to use your product.
Okay, awesome, thank you. Yeah, so as you know, I'm also in this field and have done some usability studies with fuzzing. And kind of one of the things which I've seen is that no matter how deep you go in the stack, the human factor is always there. There could always be more usability. Where would you see the balance between kind of helping developers write secure software in the first place and helping developers find problems after the fact? So, or let me ask it this way: do you think we'll ever get to a point where people can just write secure software without any problems?
Well, if they do, you and I were both looking for new jobs, right? So what I think is that we can make this easier, but we should also always rely on testing, right? So I feel that I feel like that's been the problem in the first place, that people are somehow convinced that things are secure and that they don't need, additional layers of testing, of having other people review or look at things. So I feel like this whole mindset of one person can get one thing correct for eternity, and we can just leave it at that. I feel like that's brought us many problems. So if I have to, make a choice, and not just so that you and I can keep doing our research, I would want to say that extensive testing is a pretty good idea, and that people are really terrible at getting a thing perfect on the first try without any oversight. And I think you and I can rely on this staying this way for a long time.
That's a nice closing thought. Thank you very much, Yasemin, for your presentation.